have questions. So 3.3 deals with dividing polynomials. And we're going to look at two theorems here after we study the division of polynomials, basically long division. You may remember it from previous experience with math, and factor. I'm sorry, long division and synthetic division, first of all. And then we have two theorems to look at. I can read and write tonight. Two theorems. One is entitled remainder, and the other one is factor. So the remainder theorem and the factor theorem. So we're going to look at these two. Again, we're going to look at two types of divisions. One is something that you probably remember from your previous experience with math, and the other one may or may not, you may or may not remember it, synthetic division. Okay. So let's start with long division. That's our first step, long division. The only thing that I want to mention before we look at the long division is when we divide a polynomial by one term, something like x cubed plus 2x minus 1 divided by x squared. When the denominator is one term or a monomial, in other words, one term polynomial, we will not be using long division. We will not be using synthetic division, none of the above. All we have to do here is separate into 1, 2, 3 fractions. Why 3? Because the numerator has 3 terms. In this case, separate into 3 fractions. If it has 4 terms, into 4 fractions. If it has 2 terms, into 2 fractions, and so on and so forth. In this case, I selected an example with 3. So then I will rewrite the whole thing as x cubed over x squared plus 2x over x squared minus 1 over x squared. This is a very important topic, very important. You're going to see it in the next class if you need to take another class like Math 230. This is important, very important. You can say, but this is not an actual division. I understand, and I agree. It's not. But we will have to simplify each fraction by itself. This we cannot simplify. It's done. It has to stay as is. But this has to be simplified. This has to be simplified. So, as we know, x to the third over x squared is x plus, simplify an x, 2 over x minus 1 over x squared. This is not the long division, and it's not the synthetic division. It's the only way to sort of divide a polynomial by one term. Why is this important? For other things later. So we need to be able to separate it into the number of terms that the numerator has. Okay, now we finally continue with the long division. Any questions? Okay, so again, long division. I'm going to choose an example, a problem. Let's say problem 9, and this is on page 394. You can select the next one in a minute. So we have 2x cubed plus 7x squared plus 9x minus 20, everything divided by x plus 3. So this is a polynomial. Can anyone give us a degree over this polynomial? Is anyone with me?
3.
Thank you very much. Degree 3, degree 2, degree 1, degree 0. Not the power, degree. No x, in other words. Perfect. So I identify the degree of the numerator. I identify the degree of the denominator is 1. We know it's linear. Now, a first question that I ask myself is are both, not just the numerator, but are they both in descending order? If they are not in descending order, I have to rearrange them. Are they in descending order? That's my first check.
Yes.
Yes, perfect. If not, I have to rearrange. In part B, is there a missing term in the numerator? What does that mean, a missing term? How do I know it's a missing term? Here's how I know. Since the degree is 3, the polynomial has to have everything after degree 3 in it. It has degree 3, it has degree 2, it has degree 1, and it has degree 0. This has degree 0. No. So for this particular case, no. No missing terms. If the degree is 4, I have to have degree 4, degree 3, degree 2, degree 1, degree 0. If the degree is 5, I have to have degree 5, degree 4, degree 3, degree 2, degree 1, degree 0 to consider that there is no missing term. And what's with all this? Why is this so important? You're going to see in a moment when we look at the next example in which, of course, a term will be missing. Okay, so then I can start the algorithm. Here's how I start. I put the divisor. So this is the numerator, sorry. Numerator. And this is the divisor. Okay? So the divisor goes in front. The numerator, 2x to the third plus 7x squared plus 9x minus 20, goes under the division symbol if you want. Here's my first question. X is multiplied by what term to get 2x cubed? So the answer is 2x squared. Because 2x squared times x is 2x cubed. But here's what happens next. I have to distribute 2x squared to both terms and write below like terms. Before I continue, I just want to mention something. I know we no longer perform these calculations by hand. I know that. But let's suppose I want to divide 44,522 by 12. Well, 12 goes into 45 3 times. And when I multiply, I get 39. I subtract, although 3 times 12 is not negative 39. It's positive 39. I have to change its sign because I have to subtract from 45. And I get 6. Then I bring down the next in line. And again, I ask myself, 12 times what is 62? So that would be 5, because 5 times 12 is 60. When I multiply 5 by 12, I do not get negative 60, but I have to change the sign and write negative 60 because I subtract. And then I bring down the next in line. This is gone. And I get 1, and 1 times 12 is 12, but I have to subtract. Although 1 times 12 is not negative 12, I have to change the sign, and I get 10. I can no longer divide, and I will write that 4522 divided by 12 equals 351. This is the quotient, and this is the remainder. Plus the remainder over the divisor. Yes, you will say, I disagree, and I will have to agree with you. We do not write this plus when it comes to numbers. We simply write 351 and 10 over 12, and we'll simplify it 5/6, and we get 351 integers and 5/6. But this is mandatory when it comes to polynomials. I cannot write that the answer is x plus 3, no symbol, and the remainder over the divisor. Here, it can be omitted when we talk about numbers. So we don't really write this. We write it as 351 integers and the proper fraction, simplified. But please remember, this cannot be missing, either positive or negative. Cannot be missing when we are going to write the final answer for polynomials. Okay, coming back. The point here is not just this, but the fact that I multiply 3 by 12, I get positive, but I change the sign to the opposite sign. I multiply 5 by 12, I get 60, but that's not negative 60, but I have to change the sign. So please remember this procedure because we're going to use the same procedure here. Okay, so the answer is 2x squared, but when I go back and I distribute, I get two terms, and every time I write them underneath the like terms, I have to change to the opposite sign. If it's positive, I have to write negative. If it's negative, I have to write positive. So always opposite sign. So 2x squared times x is 2x cubed, but I have to change the sign to the opposite sign. 2x squared times 3 is 6x squared. I have to change to the opposite sign and write below like terms. Gone. 7x squared minus 6x squared is x squared. I have to bring down the next in line. Next question. X times what is x squared? I do not lie now. I tell the truth. X times x is x squared. But when I distribute x times x, I have to change the sign to the opposite sign. X times 3 is 3x. I have to write the opposite. Gone. 9x minus 3x is 6x. I bring down the next in line. X times what is 6x? I do not lie. I tell the truth. X times 6 is 6x, but I need to write the opposite. 6 times 3 is 18, but I need to write the opposite. I box it in because this is negative 38. How do I write the final answer? So the final answer of the division, 2x cubed plus 7x squared plus 9x minus 20 over x plus 3 is the quotient first equals 2x squared plus x plus 6. Then the sign of the remainder, 38 divided by the divisor. The sign, when it comes to polynomials, cannot be omitted. When it comes to numbers, it can, but not when it comes to polynomials. There must be a sign here between the quotient and the remainder over the divisor, either positive or negative. Okay, let's think for a moment, ask questions, and then we'll do it again slowly with a different example. You can choose the example. And I'll show you where they are. I'm opening the book right now. Okay, this is chapter 3. Okay, and this is page 394. Don't tell me I'm logged out, please. Okay. $394. Okay. Good. So let's choose another one. Before we even choose, one other thing I wanted to say. How do I know that this is correct? What if it isn't? What if I made a bit error somewhere? Here's how I check my work. I will multiply this by x plus 3, subtract 38, and if I do not get the original polynomial from the numerator, then I know that this answer makes no sense. I'll cross it out and say, sorry, I have to start from scratch. So let's just do that before we choose another example. X times 2x squared, 2x cubed, x times x, x times 6, 3 times 2x squared, 3 times x, 3 times 6, and minus 38. 2x cubed, yes. 7x squared, yes. 9x squared, yes. 18 minus 38, negative 20, yes. This is the correct answer. I checked. It's like saying 10 divided by 3, is it 3 plus 1/3? I don't know. 3 times 3 plus 1 is 10. So it is indeed correct. This times this plus this has to give us 10. This times this minus 38 has to give us this, and it does. So I know that this is the correct answer. Quotient, remainder, divisor. Yes, I'm ready for another example. Is anyone with me, please? No one?
Can we do 7?
Yes, let's choose 7. Very good. I see it. Perfect. So this is 7 on page 394. And we have 12x squared plus x minus 4. Everything divided by 3x minus 2. Perfect. They're both in descending order. No missing term from the top. I see degree 2. I see degree 1. And I see degree 0. I can start the algorithm. Put it in the format and start asking questions. So 12x squared plus x minus 4, 3x minus 2. 3x times what is 12x squared? Also, one other thing that I want to say is this. This is degree 3. We divide by degree 1. So of course, I have degree 2, and then 1, and then 0. If you have degree 2, and then degree 3, and then degree 4, something is terribly wrong. Everything is in descending order. The answer has to be in descending order. So degree 3 divided by degree 1, obviously I have to get degree 2. But then the next one has to be degree 1. Next one has to be degree 0. And then the last one, something over the remainder. Good. So then what do I put up here? 3x times what is 12x squared?
4x?
Yes, indeed. Remember, we don't lie at the top. We don't lie at all, but you know what I mean. I just wanted to make a comparison. So this times this is 12x squared. But if I write 12 here, then I'll get 24. But that's not the case. I have 12, but I have to change the sign. Every time I write, I change the sign. Underneath, I change the sign. 4x times negative 2 is negative 8x. No, I have to change to the opposite. Gone. I perform the operations I see, and I bring down the next in line.
That's negative 8x and negative 9 plus 9x all. That's an 8 or 9.
Nobody knows what I'm doing. I don't know what I'm doing. I say one thing and I write something else. Sorry about that. Thank you. No, I wasn't trying to see if anybody's paying attention. No, no, no. I just got carried away. No excuse. Thank you. 3x times what is 9x? We don't lie. What should I have put up there?
3.
Indeed. I go back. I have to change the sign. 3 times 3x is 9x. 3 times negative 2 is negative 6. Change the sign. Every time you write underneath, you must change the sign. Gone? 2. Boxed in. How do I write the answer? Can anyone tell us how to write the answer?
4x plus 3.
I need the sign.
Plus 2.
Over
2 quotient.
3.
3x minus 2.
That's it. So this is the quotient, this is the remainder, and this is the divisor. You want to check? Let's check. 3x times 4x, 12x squared. 3x times 3, 9x. Negative 2 times 8 times 4 is negative 8x. Negative 2 times 3 is negative 6, and then plus 2. If I don't recover the numerator, this makes no sense. So 12x squared, yes. 9x minus 8x, yes. Negative 4 plus 2, negative 6 plus 2, negative 4. Yes. I checked. This is it. Any questions? Any questions? Okay, I would like to choose one. Let me see the video.